I welcome you all back to today's lesson. We are back again with another interesting topic. This is our topic 2, lesson 1, where we start looking at travel graphs. So even as we start this, I want you to get this and I want you to understand each and every point that I will be talking about. I don't want to leave you behind. So even as we start, let's begin. Okay, so we are going to first start with shapes. We need to understand shapes, the shapes that we get to use and their formulas. So let us look at the shapes that we need to use and their formulas. So shapes, the shape number one that we are going to look at is this shape. Have you seen the way this shape is? This is a what? This is a triangle. We know that this is a what? This is a triangle. Under travel graphs, what I want you to understand is that distance, whenever we are talking about distance, distance is equal to area. This is what you need to understand. Distance is equal to what? Is equal to area. So when you are told to find the distance under the graph, it's just the same as you are told to find the area. It is just one and the same thing. So I'm going to say distance is equal to, so what is the area of a triangle? This is the right angled triangle. So what is the area of a triangle? It is half BH. This is the area of a triangle. Don't know if you are able to see half BH. So this is the area of a triangle that you need to know. So half BH, where the base is this one. This is the base, then this is the height. Have you seen? So this is the base from here to there. That's the base, and this is the height. The formula that we need to know, it is this formula. This is the formula that you need to know, that you need to understand. Another shape that you can find is this one. Have you seen the way this one is like this? Any shape that will look like this, any shape that will look like this, this shape we call it a trapezium. This is a trapezium. This is a trapezium. So anything that will look like this, it can be in this format like this. It can be standing like this. It can be put in any form, as long as you know that it is like this. The same way this one is like this, like this, like this. The same way it is a trapezium. So this one is put down like this, like in a sitting position. This one is standing. But as long as you are able to recognize the shape the way it is, just know that you are dealing with a trapezium. And this is what you need to know. This is what you need to get and understand. So the formula that you get to use under a trapezium is this one. This is the formula that we get to use under a trapezium. So distance is equal to what? Half, then A plus BH, like this. This is the formula that we normally use whenever we are talking about trapeziums. So this is the formula that you need to be using. So in this case, where is your A and where is your B? For now, I just want you to know these shapes and I want you to understand the formulas. When I give an example, that's when you are going to know and tell that, okay, this is how we need to apply this. This is how you need to understand them. This is just lesson 1 under travel graphs. We are yet to go deeper than this. Everyone is going to understand. This is an important topic that don't miss in physics. So I want you to get this and I want you to understand each and every point that I'm sharing with you. So what is your A? Have you seen these two sides which are parallel? This side and this side. This side that is there and the side that is down here. These two sides are parallel. Have you seen? they can be joined by a straight line. This is going like this. This is also good. So this one and this one, these are parallel lines. The short one, it is A. From here to there, that is your A. From here to there, that is your B. Then this is your height. So our height is here. From here to there, that is the height. Hope you've seen which one is A and B. What if it is in this format? You need to locate two lines which are parallel to each other. Have you seen the way this one is like this? We also have this one like that. So this short one is called A. This long one is called B. Then this one is the height. That is joining these two one. So it can be put in any form. You are not supposed to say that this is a height because it is like this. No. It can be put in different ways. As long as you are able to know, you are able to understand what is being said. So I want you to get this, and I want you to understand this point clearly and very well. This is a point that you don't miss in an exam. Trapeziums, travel graphs, they don't miss in an exam. The other shape that we need to know, is this one. This is a rectangle. This is a what? A rectangle. That is a rectangle. Don't know if this is the correct spelling of a rectangle. We can confirm. So this is a rectangle. You know that distance is equal to what? L times B. Just needs to multiply L times B. So that's how you need to know this. That's how we need to know how to calculate this. So what is your length? This is your length. Then your breadth is this one that is here. So this is how you need to work out these. These are procedures that you need to understand. This is L. This is breadth. So when you are taught to calculate the distance under travel graphs, the distance is equal to their area. This is what you need to know. This is what you need to get and understand. So we look at another part. Let us look at another part. Another part that I want to share with you is we get to find acceleration. What is acceleration? So we get to talk of acceleration. Let us look at acceleration. We look at acceleration. So we usually talk about acceleration. What is acceleration? What is acceleration? So acceleration is the way we get to find acceleration is the change of velocity, is the change of velocity with time. Have you seen the way of find acceleration? This is a simple definition that you need to know under acceleration. So this is the definition for acceleration. The symbol for acceleration, we normally take A like that. So acceleration is just the change of velocity with time. So if I don't want to use time in my definition, I'll just say is the rate. So when you use the word rate, you don't need to include this word which is time. So there is no need of including that. You just say acceleration is the change of velocity with time. That's how you get to define acceleration. So when you are taught to define acceleration, you just say acceleration is a change of velocity with time. When you put the word rate, you just say is the rate of change of velocity. Hope you've seen the two definitions. So I'll write it for the sake of revision. Someone can say, I didn't get that clearly. So the other one is the what? Rate. So this is the other one where you just say is the rate of change. Is the rate of change of velocity. Just like that. So these are the two definitions that you need to know. If you put the rate, no need of putting time. So acceleration is the change of what? Is the change of velocity with time, or you can tell me that is the rate of change of velocity. This is acceleration. What formula do we use whenever we want to find acceleration? So in my definitions, which I've given here, there is this word I'm saying change. Change. How do you find the change? So the way you get to find the change is that you calculate the distance, you subtract the final position minus the initial position where you started from. So what you are going to do is this. This is what you are going to do. So you are going to do this. This is what you are going to do. You are going to say acceleration is equal to final velocity minus initial over time. This is the formula that we use. This is the formula that we get to calculate under acceleration. So this is the formula for acceleration. And acceleration is measured in what? Meter per second squared. Don't forget to put a square. So these are the units for acceleration. We need to know these units. So I want you to know this, and I want you to understand this. These are the basics that you need to get. These are the basics that you need to understand. So I want to break this topic to our level so that we understand each and every point that we are going to discuss together. These are simple things, and I believe we are able to know them. We are able to understand them. So you know that in this formula, A is measured in what? Meter per second squared. We've got the T. What is our T? So what is our T? Our T is what? Our T is time. Our T is time. We've got V. V is what? Final velocity. So you write it is what? Final velocity. That is your final velocity. You've got U. What is our U? I'm going to write it here. What is our U? Initial. The starting point. Initial what? Initial velocity. Complete it. You complete it. That is initial velocity. So you write it properly well. What this means. Then you know that your A there, that is your acceleration. So this is what we need to know. This is what we need to get and understand. These points are very important. You need to make sure that you get them and you understand them. Let us move forward and look at another thing. We'll look at another thing. So we are going to understand this well when I give an example. You are going to know the reason why I was even giving you all these. All these formulas are going to be used somewhere. All these are going to be used somewhere. We look at, let us look at speed. We look at speed. So speed, sometimes it can be what? Velocity. Speed sometimes can be velocity. So speed is given by the formula total distance. This is the formula that we use. Total distance, you say total distance over what? Time taken. Over time what? Over time taken. Distance is in meters, while time taken is in seconds. All in all, speed is measured in meters per second, just like this. Meter per what? Per second. This is what you need to know and understand. So it is just meter per second. I want you to get this and I want you to understand. So these are points that we get to know. These are things that we need to understand. So total distance over time taken. This is the formula that we use for speed. So even if you are taught to find the average speed Under travel graphs, we are going to find something that will be called average speed. So the average speed, that's what you need to use. The same formula, this same formula, it is the same formula that you need to use and apply. So you just say, here where the speed, here you put average speed, AS. Even here, average speed, AS, like that. So that's how you need to do it. It is just one and the same thing. Let us look at an example. So let me give an example here. We see how we can apply these things. We see how we can apply. So the question is saying, the diagram shows, write this as your example 1. This is your example 1. The diagram shows the accelerating car. Shows the finish it here, accelerating car. Shows an accelerating car. This is what you are given. Like this. You are given something like this. Here there is time. Time is what? In seconds. Here you've got speed. So there we've got speed. So I'm just going to do this. This is speed, which is in meter per second. This is the diagram which we are given. The first question which we have, the first question which we are given, we are told to calculate acceleration. Calculate acceleration in the first 4 seconds. This is the question you are given here. This is the first question. How can you go about this question? So the diagram showing an accelerating car. So this car had to start from where? This car had to start from rest. It started from rest position. So from this rest position, accelerated until it reaches that speed. It maintained this same speed. It moved with a constant speed here, but time was increasing. Then it came to rest just like that. The first question we are given is calculate the acceleration. This should be acceleration. Calculate the acceleration in the first 4 seconds. So how do you calculate the acceleration now? What formula did I give you? The formula was acceleration is equal to final velocity minus initial over time. This was the formula that I gave you. And this is the same formula that we are going to use. So how do you find the acceleration here? How do you get to find the acceleration? So acceleration is equal to, what is your final velocity? Which velocity did it reach? The highest velocity, which velocity? It started from here, 0. So initial is 0. 4 seconds is here. So 4 seconds is reaching there. So it reached a velocity of that one. What's the speed now? This is 8. So get that one. So you say 8 minus initial. Where did this start from? It started from rest position, which is 0. Then you say over time. What is your time? The time is what? In the first 4 seconds. The time is 4. You do this, which is equal to 8. You divide by 4, which is equal to 2 meter per second squared. So this is your answer. This is how you need to answer that question. So that's how you need to calculate that. And these are the procedures that you need to know. These are the procedures that you need to get and understand. Have you seen the way I've done this? This is how you also need to do it. this is just an introduction to this. So I just want to make sure that we all get the point. We all understand what I am trying to illustrate with you. So we've calculated the acceleration in the first 4 seconds. So we've answered that question. We move to the other question. Let us move to the other question. We move to the other question. So question B is saying calculate the total distance. Calculate the total distance. This is the question. How can you calculate the total distance traveled? So you are told to calculate the total distance traveled. How can you calculate the total distance from here up to there? The total distance here. How can you calculate that total distance? So as you can see, this shape from here to there. Have you seen this shape here? What shape is that? That is a trapezium. So with this one, you can use the formula of a trapezium. Then this one, which is here alone, you can use the formula of a triangle. This is a triangle which is here. I don't know if you are able to see that. This is a trapezium here. This is a triangle. So in here, we are going to use the formula of a trapezium. So I'm going to say distance is equal to half A plus B, then I put H there. So I calculate the first one. I find the first one here, where I'm going to say this one is equal to half. I'm going to put my half there. What is my A? What is my A? I check. Where is my A? This I've said that, so my concentration should just be on this part. Just this part. So which two lines are parallel? This is A. From here to there, that is A. Then from here to there, that is the B. Then here, this is the what? This is the height. So this is what you need to do. So after that now, what is your A? So from here to there, we are starting from 4 to 8. So you say 8 minus 4. This is the distance. What's the distance? 8 minus 4, it is 4. So your A is what? Your A is 4. Plus, what is your B? What is your B? What is your B? Your B is from here up to there. This is your B. Have you seen this distance here? This is your B. From 0 to 8, you say 8 minus 0, it is 8. So you put 8 there. You do that. Then what is your height? Your height is this one. This is your height. Have you seen? This is your height, which is what? Which is 8. You are done. So this is the formula that we are going to use on that one. So we just evaluate it now. Where you say this is equal to half. What is this plus that? 4 plus 8, it is 12 times 8 like this. Half of 12. What is half of 12? 6. 6 times 8 there. What answer are we getting? So 6 times 8. On this one, you are allowed to use a calculator. 6 times 8. What are you getting? 6 times 8. 6 times 8. What is our answer? 48. So 48 is our answer. So this is the first one, which is 48. From here, this is what? 48 meters. So I've calculated that one. I go to this one. This is a triangle now. I move to a triangle. So how should I calculate the triangle now? The formula for a triangle, I know that distance is equal to half BH. This is the formula for the triangle. So what am I supposed to do? I said distance is equal to half times, what is my base? This is my base. Here to there. Have you seen here to there? What's the difference here? 12 minus 8, 4. So there is a 4 there. Times height from here to there. What's the height? 8. I put my 8 there. Then you multiply everything. We say this is equal to. So on your calculator, this is 0.5. You know what half means. What is half of 4? What is half of 4? It is 2. 2 times 8. What 2 times 8? What is 2 times 8? 2 times 8, it is what? 16. So it's 16 meters. So which means here it is what? 16 meters. So we've calculated all of them. We've calculated this one from here, this whole thing here. This is 48. This is 16. So what do you do now? You just add them now. You find the total distance. So you say total distance. This is what you're going to say. Total distance is equal to. So total distance is equal to. Total distance is equal to what? Is equal to 48 meters plus what? 48 meters plus 16 meters, which is equal to 48 plus 16. It is what? 64. So you are getting 64 meters. This is your total distance. This is how you need to calculate that one. Have you seen the way I've calculated? The same way I've calculated, that's the same way you need to calculate. Then question C. The question C now, which I want us to solve together. Question C, calculate average speed. So calculate, this is our last question. Calculate average speed. Want to calculate the average speed. How can you calculate the average speed? So average speed is given by the formula. You say average speed is equal to distance. That is the total distance. So total distance over time. I've just abbreviated that. So you say average speed is equal to. What is the total distance? The total distance that we are from calculating is this one, which is what? 64. So you say 64 over the total time. What was the total time? You go to your graph. What was your total time? Your total time was what? Your total time was 12. So 64 divided by 12. What answer are you getting? 64 divided by 12. What answer are you getting? You're getting 5.3333. So 5.3 meters per second. This is how you need to answer it. And these are procedures that you need to follow. Have you seen the way I've answered? The same way that I've answered this. That's how you also need to answer it. You too. So these are steps. These are things that you need to do. These are things that you also need to work out. So let me now give you a question that I want you to answer. Let me give you a question that I want you to practice through. This is the question I'm going to test you with. So this is our exercise that we are going to do. Let us answer this question. This is the question. This is the question. The diagram shows the accelerating car. This is a car which is here. It is shown. This is the diagram. This is our diagram. So hope you can pause the video, then copy down the question. This is the question. Question 1 is saying calculate the acceleration in the first 10 seconds. B is saying calculate the total distance. Question C is saying average speed. This average speed is for the whole journey. So let's answer this question. I see if we have understood what we've gathered so far. These are the questions. You can pause, then copy them down. These are the questions. Then this is the graph. This is the graph. So let's see how we can answer it. The graph is just like this. So let's see how we are going to answer this. Let's see if we've really understood what we've learned. Thank you so much. I'm waiting for your answers. And I told you that these are private videos. Any person that is watching this video, have gotten permission from me. So if you are not under my teaching, or we've not made any arrangement for you to watch this video, then you are watching this video illegally. This video is for people under my teaching and those that I'm helping academically and have paid. So let's do the right thing. Okay, so let's make sure we don't share to any person, our friends. Let's not share these videos to them. These are private videos. I'm here to help you. So I'm waiting for your work in my inbox. My inbox is waiting for your answers. Let's see how we can answer this question. This is a question here. Let's see how we can answer it. So this thing here, it is straight here like this, falling at 18. So let's see how we are going to answer this question. Thank you so much.